College Algebra, the review chapter, section 7, rational expressions. So what is our first objective? Objective 1, of course. It is reduce a rational expression to lowest terms. In other words, simplify it. So you reduce a rational expression to lowest terms. So that's what they mean when they'll say in the directions, simplify. Hope you can read my handwriting. Anyway, so first of all, what in the heck is a rational expression? Well, sometimes, there's an I in there someplace, it's good to look at things that are examples of rational expressions, but the key, there's got to be a variable in the denominator for it to be a rational expression. If there is no variable in the denominator, say you've got x over 5, that's really not a rational expression. You need a variable in the denominator for this to be upgraded, in a sense, to a rational expression. So it's really a polynomial over a polynomial in most cases. So all these things we learn about polynomials we'll be able to use. It also means that all these rules we had for multiplying, dividing, fractions will apply. We just have to be a little more careful. So, how do you reduce a rational expression? Well, just like any fraction, let's reduce 8/36. What do? Well, you say to yourself, okay. I need some factors of this that I can cancel. So this is going to be 2 times 4, and this is really 2 times 18. So I can cancel those 2's. Well, hold. Can I do that again? See, this is 2 times 2. That's a times. And this is 2 times 9. So I can cancel the 2's. And then I get 2/9, and that's the farthest I can go. So that's what I'm going to be doing for rational expressions. Like, see, 3y squared minus y minus 2 over 3y squared plus 5y plus 2. So it would have been nice up here if I would have just factored the whole thing into the prime factorization. For 8, it's 2 to the 3rd. For 36, let's see, it's 2 times 2 times 9, which is 3 times 3, so it's 2 squared times 3 squared. And if I had all that prime factorization down to prime numbers, then I can say, you know what? 2 of these will take care of these 2, and I can't do anything else. That's the 2/9 that's left. So the reason we learned how to factor? So we can reduce rational expressions. How do we factor this numerator? Let's see. I remember trinomials. That's 3 of y. So 3y times y. That's how we get 3y squared. And the only way to get 2 is 2 and 1. But I need to get a 1 for the middle term. So I'm going to put a 2 here and a 1 here. Since it's a negative, it's got to be positive and negative. But I want the middle none to be negative. So this 3 times 1 I want to be negative, and the 3y times negative 1 and 2 times y. That should work. 3y squared and the negative 2. Here's a positive 2y and negative 3y, and that gives me the negative y. Okay. Denominator. Let's do something similar. So for 3y, it's 3y squared, 3y times y. 2, it's still 2 times 1, but this now has a plus 2. So I know both signs have to be the same. They're both positive or both negative. This middle term tells me what that is. They're both positive. So now I need to add up to 5. Well, I think this order is going to be correct here. The 2 and the 1, because this will be 2y plus 3y, which gives me the 5y. Okay, 3y squared, positive 2. Now that I've got this factored, I can cancel the factors in the numerator and denominator. So I'm going to cancel this one and this one. And what am I left with? My final answer, y minus 1 over y plus 1. Now, you might be tempted to say, well, can't I cancel the y's, and isn't this just then a negative 1? Nope. You can only cancel factors, things that are multiplied together. Because this is really, once you put in a value for y, and you calculate, this is really just 1 that you're multiplying by. That's why you can factor and cancel. But you're not multiplying by 1 here. This is adding or subtracting something. Okay. Objective 2. We want to be able to multiply and divide rational expressions. Now, these aren't equations, these are expressions, so the equal sign is just used to get us from one expression to the next. So what are they looking for here? Well, let's go back to our fractions. If we have a over b and we want to multiply by c over d, how do you multiply fractions? Numerator times numerator, denominator times denominator. And suppose we're dividing. You can write it several different ways. You've got a over b over c over d. You can write that as a over b divided by, with the divided sign, c over d. But in both cases, it's really invert the second thing or the denominator and multiply. So you never really divide. You multiply by the reciprocal of the second one. And then you get that AD over BC. So that's the sort of general rules. How do we want to do this for our rational expressions? We're going to factor first, if you didn't really recognize that before, because what we'd like to do maybe is cancel things, so this makes it a little bit easier problem. So let's find out here. We've got sort of a big problem. I'm wondering if I have enough room here. Let me go to a new screen. 9x squared plus 3x minus 2. Over 12x squared plus 5x minus 2. Divided by 9x squared minus 6x plus 1. Over 8x squared minus 10x minus 3. Now let me check my numbers here. Make sure everything is correct. Hate to get almost all the way through a problem and then have somebody say, oh, you forgot a plus sign here. Okay. What do we need to do? Factor. So this 9x squared, let's see. I know that's 2 times 1. That's what it's going to be. And I know it's going to be plus and minus because of the negative. Now, I know it's going to be 3 and 3 maybe. That's 6 minus 3 is 3. That should do it, I think. Let's see. 3x and 3x. So this is 6x minus 3x. And I got the signs correct, too. That gives me a positive 3x. Okay, let's do that for the denominator. Let's see. It's still the 2 and the 2, so I'm going to write that the same. The 2 and the minus 1. But now I got to figure out the 12. Let's see, just a second. The positive 2 and the minus 1. So 12. 3 and 4 is usually a good guess, because 3 and 4, 2 times 4 would be 8, and 3, yeah, sure. What a guess. 3x, 4x, because this is 8x minus 3x, which gives me the 5x. Now I'm going to do 2 steps here in once, because I'm going to divide by the reciprocal. I'm going to put the denominator in the numerator. So I'm factoring this one for the numerator. 3, see, plus 3 minus 3, or minus 1. The factors of 8, but I've got to come up with a positive 10. So if I do 4 and subtract 2, yep, that should work. So this is 2x, and this is 4x to give me the 8x. This positive 12x minus 2x gives me the 10x. Okay. And this is going to go for the denominator. So let's see here. 1 is 1 times 1. The signs are the same. They're both negative. 9. Let's see. 3x and 3x. I think that works. 3x and 3x. Negative 3x is negative 6x. Now that I've got all this multiplication and stuff, I'm going to look around, because you can go really sort of far down the line here, in a sense. Anything in the numerator, because this is going to just be multiplied, can cancel with anything in the denominator. So this 3x plus 2 and the 3x plus 2. Let's see, 3x minus 1. This will cancel with a 3x minus 1. Let me show that as something a little different here. Let's see, 4x plus 1 and a 4x plus 1. And all we have left is the 2x plus 3 over the 3x minus 1. So we divided by not doing hardly any division or multiplication at all. We just canceled everything. Wow. Cool. So how about objective 3? Add and subtract rational expressions. Expressions, not equations. So the equal sign is just going to go to the next expression. Well, let's remind ourselves of fractions. When we add 2 fractions together, a over b, and either that or subtract 2 fractions, c over d, we must get a common denominator. And many times it's just multiply the denominators together. But hopefully we'll be able to reduce some things here. So I'm going to take this a times d and a b times d, and either addition or subtraction. The c times b over, let me put this in order, b times d. So I'm going to get the 80 plus, or if I'm subtracting minus, the cb over the common denominator, bd. So that's the key. Get a common denominator. And that's what we're going to look for here. Suppose we have x minus 1 over x cubed. And we're adding x over x squared minus 1. Well, the first thing, and I'll probably ask this on a test, what is the least common denominator? The least common multiple is the same idea. Okay, sorry about that. That was my medicine alarm. Okay. So, In order to combine these two, we need a common denominator. In order to find the common denominator, we need all the factors. Now this says x cubed, but its factor is only x. X squared minus 1 can be factored to x plus 1 and x minus 1. So these are the three factors from the denominator, and we're going to use all three. Now we do need to use the largest powers of these. So we need that x cubed, not just x. So every factor's got to be in there and to its largest power. If this had an x, we'd have to make sure we include an x cubed, because that's the x cubed was from over here. So this got the x cubed, and I guess maybe we'll remind ourselves to put it here, I guess. So this needs an x plus 1 and an x minus 1. And if we do that to the denominator, we've got to do it to the numerator. An x plus 1 and an x minus 1. Over this common denominator, x cubed, x plus 1, x minus 1. Now I'm going to run out of room here, so I'm going to say, okay. This denominator has the x plus 1 and the x minus 1. It needs the x cubed times that numerator x, and then the x plus 1, x minus 1 times x cubed, so it's over this common denominator. So here's an equal sign. Now, the denominator I would leave alone, leave it factored, just in case you can cancel some things. The numerator we do need to multiply out. So x cubed, x plus 1, x minus 1 in the denominator, leave that alone. We need to multiply all these things. This is x to the fourth. So this is an x plus 1, x minus 1 is really x squared minus 1, right? And if we multiply that by the other x minus 1, so this is positive 1 and a negative x squared. And this is a negative x and x cubed. So this becomes x cubed negative x squared minus x and plus 1. I hope this makes sense to you. I don't have a little piece of paper by my side to put that on, but if you multiply that out, this is multiplication here. You should be able to get that. Now, if we wanted to, I guess we could factor this, but I don't think it's factorable to get any of these. We can't get a common factor so that we could cancel one of these x's. And finding x plus 1, x minus 1, I don't know. I don't see it there. So, that is our final answer. You can leave the denominator, and if you can factor the numerator and cancel any, you should, to reduce your final answer. Maybe it's not a good idea for me to just make things up. Anyway, let's go on to the next screen. So, what is objective 4? Well, we've really sort of done that. Use the least common multiple method. The least common multiple method. If you're given a simple problem as far as adding and subtracting, then and you've got the common denominator, you don't need to do what we did for that last problem. But if you aren't given that, then you have to essentially figure out your own denominators, your least common denominator, which is the least common multiple. So if you didn't need to use this least common multiple method, what does this thing look like? This is for the not using it. So if you had 2x minus 5 over 3x plus 2, and you wanted to add x plus 4 over 3x plus 2. You wouldn't need the least common multiple method or least common denominator method because you have a common denominator. You put your answer over the common denominator. 2x minus 5 plus x plus 4. Also, be careful if when you subtract, you're subtracting both of these. Change the sign of both. But our final answer then is, see, 2x plus x is 3x. Negative 5, positive 4 is negative 1. And you have that over the common denominator, 3x plus 2. But if we want to use that method, well, if we need to, 2x minus 3 over x minus 1. Suppose we're subtracting 2x plus 1 over x plus 1. I will probably ask for the least common denominator, because that'll show me that you understand. I've got to use both of these factors. Don't have to factor anything because it's already factored. Both of these need that. So this 2x minus 3 also needs that x plus 1 minus the 2x plus 1 needs the x minus 1 over the common denominator, x minus 1, x plus 1. Now, you need to multiply this numerator out, but leave the denominator alone. You may be able to factor the numerator and cancel. So this is 2x squared negative 3x, positive 2x, so it's a negative x, and a negative 3. I'm going to squeeze this in again. Minus, though, we're subtracting all this stuff, minus 2x squared. This is a 1x and a negative 2x, so this is really negative x, but you're subtracting it, plus x. And this is a negative 1, but you're subtracting it, plus 1. And what you notice here is 2x squareds cancel, the x's cancel, a negative 3 and a positive 1 is going to be a negative 2. So your final answer is a negative 2 over the common denominator, x minus 1, x plus 1. So, couldn't cancel anything here, but you can leave it that way. What is objective 5? Well, it's the last objective, I guess, in this section. Simplify complex rational expressions. Not equations, expressions, so the equal sign is just going to be to the next expression. And this is when you got a fraction over a fraction, and it really goes back to division of stuff. You've got to invert and multiply. You got to take care of the numerator and denominator to get them to look like a fraction over a fraction. Once you have it in this form, which means you might have to individually work with the numerator or denominator, then you can use what we know about dividing and change it into multiplication. This asterisk over star. So complex fractions are really just sort of a mix of fractions all over the place. Let me put it up here since this is going to be sort of our guide. How about 1 minus x over x plus 1 over 2 minus x minus 1 over x? Well, first let's work with the numerator. In order to combine these two, we need a common denominator. The nice thing about 1 is it can be anything over the same thing. Since I need x plus 1, it'll be x plus 1 over x plus 1 minus x over x plus 1. Now that means that our numerator can be combined into x plus 1 minus x over the common denominator, x plus 1. Now you work with the denominator. Same idea applies here. It's a little bit nice. 2 is the same as 1. It's really, we need an x over x because we need a common denominator of x. So it's 2x over x. That's an x. Minus x minus 1 over x. Well, now we can combine the denominator's fractions. 2x minus, now be careful, this is an x minus 1 that you're subtracting, all of that, over that common denominator x. So this then becomes, let's see, x minus x. So this is just 1 over x plus 1 over 2x minus x is just x, and minus a negative 1 is plus 1 over x. But we want to invert and multiply, right? So 1 over x plus 1 times x over x plus 1. And we can even just sort of write it almost that way. This is x plus 1 might be good to write as x plus 1 squared because we're multiplying it together. That is our final answer. So, that's all of section 7, the review chapter, working with rational expressions. Now, you should be able to do your homework, hopefully. If not, send me an email.